Hi, I'm Bill Noble, and I'm presenting the results of a project on semantic shift in social networks. This is joint work with Asad Sayeed, Raquel Fernández, and Staffan Larsson. It's well known that words change in meaning over time. Also, words are meaningful not intrinsically, but with respect to the community in which they're used. This naturally raises the question of how different communities experience semantic change differently. Simulations and laboratory experiments have suggested that the structure of a community can affect how quickly or in what ways words change in meaning. So in this project, we wanted to look at how semantic change happens in different communities in the wild. So we look at corpora from social media and use distributional semantics to measure semantic change. Specifically, we use a corpus of Reddit comments. We identify 46 communities that have enough comments in both 2015 and 2017 that we can build diachronic corpora of both time periods. And then in addition to the community-specific corpora, we use a generic Reddit corpus of comments from all of Reddit, which is much larger than any of the community-specific corpora. And we'll see why we need that. So the model of semantic change that we're using is the diachronic skipgram model, which is from 2014 by Kim and colleagues. So it takes the ordinary skipgram model, which tries to guess for a given word whether another word was drawn from its context window or not, and makes it diachronic by training essentially two different models or multiple models on different time periods. So our procedure is adapted from one that was also used to train community-specific representations, although we do it for many communities. So basically, we train a base model with that larger generic Reddit corpus, and then fine-tune that base model to get the community-specific corpora for the first time period. Then each of those community-specific corpora is further fine-tuned with the 2017, the second time period data, to get two models, one for each time period for each community. Then also we do train a generic 2017 corpus as well, and that's because we want to differentiate between semantic changes that are happening at the community level and semantic changes that are happening in the lexicon more broadly. So with these sort of aligned word vectors for 2015, 2017, the most straightforward way to measure semantic change is to use cosine distance between them. And we actually use angular distance, which is a related similar metric that scales between 0 and 1. So the reason we call this a naive cosine change is that there's a problem here, which is that it is inherently biased towards words that appear in more variable contexts. And that property has a strong relationship with frequency. So to see why that is, I mean, essentially the model is picking up noise between the two time periods. So if a word happens to appear in more variable contexts, the contexts have more variance, then it will just by chance be more likely that there's an appreciable difference between the 2015 and 2017 corpora that the model can learn. So the model basically learns to adapt to this noise. So this is what the naive cosine change on the y-axis versus frequency looks like. It's clear that there's a relationship with frequency. And if we look at the words with the highest cosine change, they are these sort of discourse markers or discourse connectives. And they're quite the same between different communities, which suggests that we're not really picking up the thing that we're interested in. So in order to address this, we use this method from Dubowski and Weisenhall from 2017, where we shuffle the diachronic corpora and then create pseudo-diachronic corpus for each community. And then we do that 10 different times and measure the naive cosine change on the pseudo-diachronic models. So the cosine change on the pseudo-diachronic models is purely picking up noise. It can't be picking up change since they were shuffled. And then we define rectified change as the number of standard deviations above the change measured, quote unquote, change measured in the pseudo-diachronic models, the actual change is. So this gives us a sort of a confidence interval for which changes are genuine and which changes are purely just due to noise. So if we look at the now this is the same graph as before, but it's rectified change on the y-axis, still frequency on the x-axis. And now the list of most changed words is quite different. All of these words were sort of buried down below before, and the words that appeared on the highest naive cosine change list are all much lower. In fact, only one of them is above the 95% confidence interval, which is this the red dots are that. And then also these lists of words for each community. So this is just for the r/Toronto. These lists are quite different between communities, with the one exception of 2016. And I would imagine that's because in 2015, 2016 is in the future, and in 2017, 2016 is in the past. So we see some change in usage there that's consistent across communities. But other than that, they're quite particular to the different communities. What we're going to do next is an exploratory analysis where we use some features to predict semantic change. And we select features at both the community level and the word level. So the community level features we're looking at are the size of the community, which is defined by the number of active members, stability, which is going to be the Jacquard index between the 2015 and 2017 active members. So the membership overlap between 2015 and 2017. And then clustering coefficient, which I'll talk about in a moment. And then for the word level features, we look at frequency of the word in the specific community corpus, change in frequency between 2015 and 2017, which is just a difference. And then generic rectified change, which is why we trained the generic 2017 model as well, because we're interested in which changes are specific to a community and which ones are just following broader trends in the lexicon. And then, of course, the community-specific rectified change will be our dependent variable. So for each community, we defined a social network model where the vertices are members of the community, and then we draw edges between members who have at least 2 interactions in a given time period. We used 2015. And then a clustering coefficient measures, so it's first defined on the user level. It measures the proportion of a user's friends or direct contacts who are also friends of each other. At the community level, it's just this metric averaged across members of the community. So you can see that this subgraph of XJW has much denser clustering than this subgraph of relationships. We put all of these features into a linear mixed effects model with the generic, or rather community-specific rectified change as the dependent variable. And we also add a community random intercept. So what our goal with this model is to assess the relationship between semantic shift and the community level features, but then also account for mediating effects among the word level features. So here are the results for the word level features. We find all of the word level features and their interactions are significant. And in particular, there's a negative relationship with frequency, which replicates some previous results, and a positive relationship, quite a strong positive relationship with change in frequency, which has also been observed before. And then an interesting result here, I think, is the interaction between change in frequency and generic rectified change. So this suggests that if there is a change going on at the sort of level of the lexicon, a higher level, so in the generic Reddit corpus, if there's a change going on in meaning, then that changes in frequency in the community of that word are an indicator that that generic change is being adopted by the community. So that's a kind of interesting result. On the community level, we have mostly negative results. Only the community intercept and the interaction between all three of the community level features were significant. So that the community intercept was significant suggests there probably are other community features that impact semantic change. And in the next slide in here, this sort of illustrates the relationship between the three features. So for communities with low clustering, community stability is positively associated with rectified change. So more stable communities with low clustering experience more change. Now for medium and high clustering, so this is high clustering is 1 standard deviation above the mean, at least 1 standard deviation above the mean. Those communities, stability is positively associated with change if the community is small, but if the community is large, then stability is negatively associated with change. So for communities that have a high clustering coefficient, it's actually more likely that you'll see semantic change if there's a lot of change between the membership. And you can sort of imagine some stories about why that might be, that appeal to sort of stability of common ground between members. So in future work, we'd like to see how these results generalize to different communicative settings and timeframes. We'd like to see what kinds of changes are taking place. So are the changes as a result of broadening or narrowing? What role do metonymous and metaphorical usages play? And then how community-specific changes are introduced and propagated. Where do the members who introduce those changes sit in the social network, et cetera. So thank you for watching, and I'm happy to take questions during the question period. Thanks.